Welcome back to Element 14 Presents. I just came back from the year 1998 to play my favorite strategy game, Seven Kingdoms. But I don't have to make that trip anymore, because it's now open source and we're gonna make a project with it. Seven Kingdoms is a real-time strategy game that came out in 1998, same time as Age of Empires. You can guess which one was a bit more popular. But it still has a cult following. I still play it 20 years later. 25 years later, oh god. Anyway, I always thought it has like an arcade feel to it. It's less of a simulation, more of like a casual round of like a board game. It feels like more like that. And I thought it could be really good as an arcade port. So let's build an arcade machine that runs that old game. And since it's now open source and it's available on Linux, we could make it run on a single board computer. Behold the elusive Raspberry Pi 4. And because I know it's really hard to get now, we're gonna use different SBCs. We try to run it on the lowest, oldest hardware we can find, so you have a chance of scoring maybe a used one or using one that you have already got from an old project. So let's try whatever here, a Raspberry Pi B+, original B+, A+, free A+, and a BeagleBone. So let's see how low we can go on specs and still run a decent game of Seven Kingdoms. As an arcade port, of course, it needs an arcade cabinet, arcade controls and fancy lighting decor and stuff. So I thought I could draw up an arcade cabinet in FreeCAD, which I could, but it would take forever and I'm probably making so many errors that I would waste a lot of wood prototyping that. So instead I use a homepage called boxes.py, which is made to create or generate boxes via Python script for laser cutting. Here is a super handy homepage for you if you want to make laser cut patterns. Boxes.py has a lot of Python scripts that basically do that for you. You can make boxes and stuff in all kinds of shapes, but also under miscellaneous. There is arcade desktop machine, and I just have to enter the dimensions of my screen, which is 440 millimeters by 300. And I want to have a keyboard depth of 150. My material happens to be 3 millimeters, and I want to have SVG output, because that is easy to alter with Inkscape, VisiCut, Lightburn, the programs you usually use. And here is our pattern. And these pieces are really big. Let's see if we can fit that on the laser. I don't think so. But the other ones, that looks like I can cut that with my laser, which is 600 by 400 millimeters. And that looks taller than 400. That's probably 600 by 600. Let's see. The size of the arcade case is completely dependent on the screen I use. And I got this old ThinkVision screen. You may recognize it from a previous video, but you're wrong, because I got two of those. Anyway, I'm gonna measure that screen and put in those measurements into boxes.py to generate a case that will hold the screen. It's also important that you know how big your controls are, because the front portion is also generated with a specific value. So if you happen to have really big buttons or joysticks, make sure that you have enough room on there. I'm using Lightburn to generate the files from my laser cutter. And by the way, the whole Lightburn project is also available in our download section at element14.com. And now it's time to turn this into stuff like this with my laser. And of course, I need my safety goggles for that. Ow! it's time to make Seven Kingdoms run on the lowest spec hardware possible. From back in the day, I know this would run barely on an 800 MHz CPU. I ran it on a 1.2 GHz Pentium 3. So the 1 gig settings of a Raspberry Pi B Plus should be enough. Let's see. Conveniently, it's available in a lot of repos. A repo, aka repository, is basically, think of it like the App Store on your phone. So you can install software that works on your operating system directly from there. And on Linux machines, you usually use the terminal and type in sudo apt install whatever kind of software you want to install. You have to know how it's actually called in the repo. And Seven Kingdoms is called 7KAA for Seven Kingdoms Ancient Adversaries. We can install that directly on Ubuntu, Debian, Raspberry Pi OS, because they're all belonging to the same family of Linux flavors. We can also compile it from scratch because it's now open source, but that is only for the game code and the graphics. I think the music is still copyrighted, so if you're gonna use that, make sure that you don't show it in the video. Note to editing, Clem. Remove the music and put something nice over it. This is 7kfans.com, the new home for the now open source Seven Kingdoms. And of course there's a download section where you can get a 32-bit Windows installer. If you are trying to install it on a 64-bit system, it's better to compile it from scratch. And also you can compile it from scratch for Linux, or you can download it directly from the Linux repo for your distro if it's in there. If not, on the community tab there is a tab building from source, and this tells you what to do. It's just a few commands, but you may have to make sure that you have all these dependencies already installed. And those can be a bit tricky to track down for your operating system. Okay, what do all these have in common? They are all running on ARM processors. What does Seven Kingdom not have in common with them? It's software that wasn't written for ARM processors. It's written in C, and it was made for x86 computers, mostly Pentium machines back in the day. So it's not natively running on there. It's running under Linux on x86 computers flawlessly, but it's not running on these for longer than a minute. And bus error, I had to Google that a lot, usually refers to through errors that when a program tries to address a certain location in memory that is not present, then you have a bus error because it just can't find that. And maybe there's some bits of hard-coded code in the code that addresses a certain memory location that's not present, or a certain instruction that's not present on ARM processors. Well, you're gonna run into problems. I tried recompiling the whole thing from scratch, thinking that maybe it's some compile issue because it, like the version was done for normal computers, not necessarily for ARM. Well, it compiled, but it had the exact same issue, like 2 or 3 minutes of gameplay, then it just throws the bus error and it's off. So we have another option, another single board computer that I have laying around for quite some time, actually since it launched in, I think, 2016. The original Latte Panda, and this one has an x86 processor, which just gives us an easier time. And because we have already shown you how to install it on Linux, I'm gonna force myself to use the plague, and we're using the Windows 10 install that is already on here. As much as you know, I'm like the open source guy and the hater for that sort of OS. Credit where credit is due, it runs beautifully under Windows 10. It takes forever to boot, but once the game is running, it's flawless. And with the Latte Panda, we have solved another problem that I haven't really told you about. The light effects for the marquee.
Hi, I'm David from Element 14 to the Electronics Inside. Join me as I tear down toys, tools, appliances, modern, vintage, classics, and even some new releases, just to find out what's inside.
Longtime viewers will know that I'm like absolutely not into blinky LEDs and stuff, which hurts me more than it should. But I've got these Neopixel strips, and I want to have the marquee emit a light effect that just changes over the gameplay. So it's a little more lively as like a static display. I've cut out recesses in the case to have lighting effects shine through it. And of course I want to do that in an animated way, not just on-off. So I'm gonna use these. And my first idea was of course to run it directly on the GPIO of the Raspberry Pi. Thing that I encountered it, for some reason NumPy doesn't like to work on the older Raspberry Pi models anymore. I think there might be some dependency issues, maybe. On the newer models, the timing is off. These need really precise timing, and Raspberry Pis are not known for having precise timing because they're not real-time microcontrollers, they are general purpose computer IOs. So something like an Arduino is a lot better at driving high-speed stuff that needs precise timing, like these Neopixels, than a Raspberry Pi is. You can make it work, but it just had glitches, just wouldn't work right. So I made a little adapter board, which also conveniently provides power for our amplifier, for the sound, and takes the power in and puts it also to the Neopixels. And it has this thing on here, which is a little ESP8266 module that I programmed with roughly the same code, just in Arduino, and it runs our strips. Problem now? We didn't use a Raspberry Pi anymore. We switched to a Latte Panda. So I have to redo that. There's one feature that sets apart this old Latte Panda from all the other SBCs, and it's not that it's Intel based, because there are Intel NUCs and stuff. It's that under this portion here, there's an Arduino directly on the board. A 32U4 chip, which is basically an Arduino Leonardo directly on this thing, which can also act as a human interface device, makes it pretty much ideal for portable handheld gaming stuff. If you want to see such a project, let me know. But this thing is also great at driving Neopixels, and it's directly controlled from the CPU. That means I can independently over the host computer program it, and that will always run no matter what the computer does. So I can basically have it do the light effects completely independently. It won't mess up any timing, but they still can communicate in case I want to change things. So let's hop on over to the Arduino IDE and check out some code. Welcome to my computer and the Arduino IDE. We basically only need the Adafruit Neopixel basic example to do all that we want, but first we have to select the right microcontroller. On the Latte Panda there is already an Arduino Leonardo, or an ATmega 32U4, which is the exact processor it uses, so you just select that from the menu. And then we have to change the pin to pin 9 and the number of Neopixels to 26. And that is pretty much all the adjustments, because I happen to want to know that this should be outputting green pixels only and just fade through it, which is the example. But I have to change this. The new GRB tells the order of bits to the program, which is green, red, blue, but my strip actually needs red, green, blue. So I want to be that in green, and this only happens if it's green in the middle. And to flash that, all we have to do is get that code on the Latte Panda. You can either write it already there, or like I do, write it on your main PC, put it on a stick, import it into the Latte Panda via USB stick, and open the Arduino IDE on there and click on Flash. And that's it. And here's a thanks to Andy Workshop Chat on the Element 14 community, who told me that you can change the boot behavior of the Latte Panda in the BIOS, because usually you have to push a button on the board to make it boot. But if you change that settings in BIOS to boot up whenever there's power applied, like on a Raspberry Pi, then I can do it that way and have just one central switch on the outside that shuts off and shuts on the whole thing at once. So thanks, Andy. For the controls, I decided to emulate the mouse controls of the original game with this trackball. And I have buttons left and right, which are the mouse click keys. So no matter if you're a lefty or a righty, you can use it both ways. You just have to switch the connections inside. This trackball acts as a PS2 mouse. There's a simple converter from PS2 to USB in there, and that will translate all the mouse movements and also your mouth movements. Yeah, and no matter if you prefer to play this way or that way or that way, you can basically do whatever you want. In the upper portion we have the Seven Kingdoms marquee. We have two speakers, pretty beefy ones, and an amplifier in there, and this knob controls the volume, and also when it's clicked, then it's completely off. Yeah, and this is how you control the sound. Nifty little detail, this panel is too big for my laser cutter, so I had to cut it in 2 sheets, and this little Celtic knot pattern basically covers up the seam. So it's not so obvious that it's made from 2 different sheets. Power supply for the display and for the Latte Panda are inside, and we have a single power plug going in with a separate on-off switch. The moment you power this on, the whole thing will boot up and go straight to the game. And when you have shut it down, then you just have to push this button to also shut down the light effects. Usually I would hold the project now, but it's just too heavy. If you want to make your own arcade machine, all the code files is on the Element 14 community for download for free. You can also go there to suggest new episodes. Like, what retro thing would you like to build? Something that reminds you of the good old days? Let us know in the Element 14 community. I gotta go. There's another project waiting for me.